Hello everyone. Today we are going to do 5 numericals based on indeterminate trusses. Let us do the first numerical. In this one there is no specific condition. We have to just find the member forces of the truss. First we have to find the degree of static indeterminacy, that is dSi plus dSe. First let us find dSi, that is the internal degree of static indeterminacy. The formula is m minus 2j plus 3. M is the number of the members. Let us count the members. 1, 2, 3, 4, 5, 6. So M is 6. J is the number of the joints. Let us count the joints. 1, 2, 3, 4. So J is 4. For DSI, we will get 1. Let us find the degree of external static indeterminacy, that is R minus R. Capital R is the total number of the reactions to be found out. In the points A and B, there are hinged supports. We know that in the hinged supports, there will be 2 reactions. So at A, we need to find 2 reactions, and at B also, we need to find 2 reactions. So caps R is 4. Small r is the available static equilibrium conditions. There are 3 conditions available. Sigma m is equal to 0, sigma v is equal to 0, and sigma h is equal to 0. So small r is 3. For DSE, we will get to 1. So the degree of static indeterminacy will be 1 plus 1. We will get 2. Since there is one internal degree of indeterminacy, we have to release any one of the member in the truss. To keep it easy, we need to remove AC or DB. I am going to release AC. Also, we have external static indeterminacy, that is 1. In the hinged support, there will be one vertical reaction and horizontal reaction. Out of these 4, we need to release any one of them. I am going to release the horizontal reaction at B, that is HB. So we are releasing HB and the member force FAC. You can see that I have removed AC. Also, I have released the horizontal reaction HB. Previously in the point B, there was a hinged support, but right now there is a roller support. We know that in the roller support there will be only one reaction. Here there is only vertical reaction. Now let us draw the coordinates diagram. In this analysis there are 2 coordinates because we have released 2. Let us keep HB as the first coordinate and FAC as the second coordinate. Let us assume that HB is acting towards the right side, and let us assume that FAC is tensile. Finally, if we get any negative value, we have to change the direction. We know that these are the 2 equations we are going to use to find HB and FAC. P1 will be HB because that is our first coordinate. P2 will be FAC because that is our second coordinate. In this numerical, there is no external deflection. So delta 1 and delta 2 will be 0. Finally, we will get these 2 equations. Then we have to make this table. In the table, first we need to enter all of the members. Then we have to enter the values of P, that is the member forces in the released structure. Now we are going to find the member forces in the released structure. Before that, we need to find the reactions. In the point A, there is a hinged support, so there will be 2 reactions. And at B, we have a roller support. Here there is only vertical reaction. First, I am going to find the vertical reaction VA. For that, I am going to take moment about B. Let us keep clockwise as positive and anti-clockwise as negative. VA is acting in the clockwise direction, so it will be positive, and the distance is 8, so 8 VA. This load 16 kN is acting in the clockwise direction, so it is also positive, and the distance is 6. This load is acting in the anti-clockwise direction, so it will be negative, and the distance is 8. For this load, there is no perpendicular distance, so we should not take it. For VA, we will get 20 kilonewton. Let us apply this rule and find VB. VA and VB are acting upwards, so both of them are positive. These two are acting downwards, so both of them are negative. For VB, we will get 60 kilonewton. Let us apply this rule and find HA. This is acting towards the right side, so it will be positive. HA is acting towards the left side, so it will be negative. For HA, we will get 16 kilonewton. Now we can find the member forces. First, I am going to take the joint A and find the member forces. First, let us apply this rule. FAD and 20 both are acting upwards, so both of them are positive. For FAD, we will get minus 20. Let us apply this rule. 16 is acting towards the left side, so it will be negative. FAB is acting towards the right side, so it will be positive. For FAB, we will get 16 kilonewton. Now let us take the joint C and find the member forces. First, let us apply this rule. Both of them are acting downwards, so both of them are negative. For FBC, we will get minus 48. Using this rule, we will come to know that FCD is equal to 0. Now we are going to take the joint B and to find the member force BD. Before that, we need to find this angle. Let us keep this angle as theta. Let us take this triangle. In this triangle, let us use the tan theta formula. That will be the opposite side upon adjacent side. The opposite side is 6 meter. The adjacent side is 8 meter. So 6 upon 8. For theta, we will get 36.87. Let us use this rule and find FBD. FBD is inclined. We have to resolve it in the horizontal direction. To keep it horizontal, we need this angle. So with the FBD, we have to multiply cos 36.87. Since it is acting towards the left side, it will be negative. FAB is acting towards the left side, so it is also negative. Just before we have found FAB, we can apply that. For FBD, we will get minus 20. Let us enter all of the values of P. Now let us see how to find the values of K1. To find the values of K1, we have to remove all of the loads from the truss. Then we have to apply unit load in the direction of the first coordinate. Our first coordinate is HB. So in the direction of HB, we have to apply unit load. You can see that I have removed all of the loads and I have applied unit load in the direction of HB. Before finding the member forces, we have to find these three reactions. Let us take movement about B and find out VA. VA is acting in the clockwise direction, so it will be positive, and the distance is 8, so 8 VA. For HA, unit load and VB, there is no perpendicular distance, so except VA there is nothing, so 8 VA will be equal to 0. So for VA, we will get 0. I have removed VA. Now using this rule, for VB, we will get 0. Let us use this rule and find HA. HA is acting towards the left side, so it will be negative. The unit force is acting towards the right side, so it will be positive. For HA, we will get 1. Now we are going to find the member forces. In this structure, except AB, all of the member forces are 0. If you do not know how to find the zero force members, there is a link in the description. You can click the link and watch the video. Let us take the joint A and find the member force in AB. This is acting towards the left side, so it will be negative. And this is acting towards the right side, so it will be positive. For FAB, we will get 1. Let us enter all of the values of K1. Now let us see how to find K2. We have to remove all of the loads from the truss and we have to apply unit force in the direction of the second coordinate, that is FAC. So in the direction of FAC, we have to apply unit force. You can see that in the direction of FAC, I have applied unit force. In this structure, there is no external load. We have only internal force. In this case, these three reactions will be 0. We can remove all three of them. You can see that I have removed them. We have calculated this angle as 36.87. So this angle also should be 36.87. And this angle will be 90 minus 36.87. So it will be 53.13. Let us take the joint A and find the member forces. Let us apply this rule. FAD is acting upwards, so it will be positive. We have to resolve the unit force in the vertical direction. To keep it vertical, we need this angle 53.13. So with the unit force, we have to multiply cos 53.13. For FAD, we will get minus 0.6. Now let us apply this rule. We have to resolve the unit force in the horizontal direction. To keep it horizontal, we need this angle. So with the unit force, we have to multiply cos 36.87. Since it is acting towards the right side, it will be positive. FAB is acting towards the right side, so it is also positive. For FAB, we will get minus 0.8. Due to the symmetrical nature of this truss, the member force in AB and DC will be same. The member force in AD and BC will be same, and the member force in AC and BD will be same. If this is 1, this also will be 1. Even though we have this shortcut, still we will calculate them. Let us take the joint C and find the member forces. We can use this rule. If BC is acting downwards, so it will be negative. We have to resolve the unit force in the vertical direction. To keep it vertical, we need this angle. So with the unit force, we have to multiply cos 53.13. Since it is acting downwards, it will be negative. For FBC, we will get minus 0.6. Let us apply this rule. FCD is acting towards the left side, so it will be negative. We have to resolve the unit force in the horizontal direction. To keep it horizontal, we need this angle. So with the unit force, we have to multiply cos 36.87. Since it is acting towards the left side, it will be negative. For FCD, we will get to minus 0.8. Let us take the joint B and to find the member force in BD. We can use this rule and to find the member force in BD. FAB is acting towards the left side, so it will be negative. We have to resolve FBD in the horizontal direction. To keep it horizontal, we need this angle. So with the FBD, we have to multiply cos 36.87. It is acting towards the left side, so it will be negative. Just before we have found FAB, we can apply that. For FBD, we will get 1. Let us apply the values of K2. As I told before, the values of AB and CD are same. BC and AD are same. And finally AC and BD are same. Now we are going to enter all of the lengths of the members. Length of AP and CD is 8. Length of AD and BC is 6. To find the lengths of AC and BD, we can use Pythagoras theorem. Root of 8 square plus 6 square, we will get 10 meter. Let us enter all of the lengths. Then we are going to enter the values of areas. The areas are given in millimeter square. We can convert them into meter square. Let us enter all of the areas. Then we need to find these. We need to add these. Then we have to write the summation here. Using this formula, we can find delta 1L. Using this, we can find delta 2L. This is the formula to find delta 11. This is the formula to find delta 12 and delta 21. And this is the formula to find delta 22. For all of the members, the Young's modulus is the same. So no need to enter that. It will be eliminated. In this one, we can apply all of them so that we will get these two equations. Solving these two, we will get P1 and P2. We know that P1 is HB. For P1, we have got a negative value. That means the assumed direction is incorrect. We have assumed HB to be acting towards the right side, but actually it is acting towards the left side. For P2, we have got positive value. That means our assumption is correct. FAC is a tensile. Then using this formula, we can find all of the member forces. If we get positive values, that means the member forces are tensile. If we get negative values, that means the member forces are compressive. In the truss, I have entered all of the member forces. Using the rule sigma h is equal to 0, we can find HA. For this particular truss, the vertical reactions are the same as the vertical reaction which we calculated in the released structure. Now we are going to do the second numerical. If the member AC is short by 2 mm, find the forces in the members of the truss. In this numerical also, I am going to release HB and the member force FAC. In the previous numerical, we had the option of releasing any one of the member, but here we must release AC because that is only short by 2 mm. Our first coordinate is HB. There is no change in HB. So delta 1 will be 0. Our second coordinate is AC. The member AC is short by 2 mm. If the member is short or long or it has expanded, that is called lack of fit. If it is short, that will be in the direction of tension. If it has expanded, that will be in the direction of compression. In our case, it is short, so it will be in the direction of tension. Our coordinate is also tensile. So this value should be taken as a positive. We have to convert this value into meter. 2 upon 1000, we will get 0.002 meter. So delta 2 will be positive 0.002. In these two, let us apply these two values. Delta 1 is 0 and delta 2 is 0.002. These we have already calculated. In these two, we can apply all of the values. When we apply in this one, we will get this. We can eliminate E then, so that we will get this equation. In this equation, we can multiply all of the terms with the Young's modulus E. Then we can eliminate, so that we will get this equation. In this equation, we can apply the value of E. Finally, we will get this equation. Now we have two equations. Solving these two, we will get HB and FAC. For both of them, we have got positive values. That means the assumed direction is correct. Then using this formula, we can find all of the member forces. Here in the truss, I have entered all of the member forces. Now let us do the third question. Find the forces in the truss if the temperature in the member AC rises by 30 degrees Celsius. The coefficient of thermal expansion is given. In the member AC, the temperature rises by 30 degrees Celsius. So there will be some expansion of the member. This is the formula to find the expansion. Length into alpha into T. Length of member AC is 10 meter. Thermal expansion is given. We can apply that. And the temperature is 30. We can apply that also. In the previous question, the member AC is short, but now it has expanded by 0.0036 meter. We know that if a member is short, that will be under tension, but if it is long or it has expanded, that will be under compression. In our case, it has expanded, so it will be under compression, but we have kept our coordinate as a tensile, so this value should be applied as negative. So delta 2 will be minus 0.0036. For HA, there is no change, so delta 1 will be 0. Let us apply both of the values here so that we will get these two equations. In this one, let us apply all of the values so that we will get this. Then we can eliminate E. Finally, we will get this equation. In this one, with all of the members, we can multiply the Young's modulus E, so that we will get this equation. Then we can apply the Young's modulus. Finally, we will get this equation. Now there are two equations. Using the calculator, we can solve both of them. For both of them, we have got negative values. That means the assumed directions are incorrect. HB is actually acting towards the left side and FAC is actually compressive. Now using this formula, we can find all of the member forces. Here in the truss, I have entered all of the member forces. Now we are going to do the fourth question. Find the forces in the truss if the horizontal support at B yields by 10 mm towards the right side. Our first coordinate is the horizontal support at B, HB. It yields by 10 mm towards the right side. We can convert that into meter, so we will get 0.01 meter. The yielding occurs towards the right side. We have kept our coordinate also towards the right side. So we have to apply this value as positive. So delta 1 will be 0.01. In the second coordinate AC, there is no change. So delta 2 will be 0. We can apply both of them in these two so that we will get these two equations. In this equation, let us apply all of them so that we will get these. Then we have to multiply all of the terms with the Young's modulus E so that we will get this equation. We can apply the value of Young's modulus. Finally, we will get this one. In this one, let us apply the values so that we will get this. We can eliminate Young's modulus so that we will get this equation. Using a calculator, we can solve both of these equations. After solving, we will get HB and FAC. Using this formula, we can find all of the member forces. Here in the truss, I have entered all of the member forces. Now let us do the fifth question. Find the forces in the truss if the truss is having combined effect of 3 and 4. So in the member AC, there is rise in temperature by 30 degrees Celsius. Also, the support at B yields by 10 mm. In this case, delta 1 will be 0.01, delta 2 will be minus 0.0036. In these two, we can apply these two so that we will get these two equations. In these two equations, we can apply all of the values so that we will get these two equations. Let us take this equation. After simplifying this equation, we will get this one. And after simplifying this equation, we will get this one. Using a calculator, we can solve both of them so that we will get HB and FAC. Then using this formula, we can find all of the member forces. Here in the truss, I have entered all of the member forces. Now we are going to end this session. Thank you for watching this video.